Welcome to the November 2022 meeting of the Mornington Peninsula Astronomical Society, and I'll start off with a couple of things that have occurred in the last month. So we'll begin with this one to refresh your memory.
SRB hydraulic power units have started. T-minus 21 seconds, and the solid rocket booster engine gimbal now underway. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Challenger. Good roll program confirmed. Challenger now heading downrange. Engines beginning throttling down now at 94%. Normal throttles for most of the flight, 104%. We'll throttle down to 65% shortly. Engines at 65%, 3 engines running normally, 3 good fuel cells, 3 good APUs. Velocity 2,257 feet per second. Altitude 4.3 nautical miles, downrange distance 3 nautical miles.
So the 25th Space Shuttle mission is now on the way after more delays than NASA cares to count. This morning it looked as though they were not going to be able to get off.
1 minute 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles.
Looks like a couple of the solid rocket boosters blew away from the side of the shuttle in an explosion.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
Has to be understatement of the year, that one, a major malfunction. A couple of things. Solid rocket boosters on the space shuttle, of course, are the same ones pretty much that were on Artemis, so same sort of technology involved. In the case of the space shuttle, of course, in this particular case, it was the infamous O-ring that got brittle in the cold weather. But what actually caused the explosion was one of the solid rocket boosters came loose and punctured through the liquid oxygen, liquid hydrogen tanks, so they mixed, and that great big cloud of stuff there was basically water vapor, where the two combined together to form water. And these bits and pieces here are the debris falling down. Now, I was actually in Houston, not at the time of this one, but at the time of the second disaster in 2003, when Columbia came to grief, coming in, and being in the company that I was in, some of the astronauts had spouses and partners that were in the same company that I was in, and got talking to one of them, and the astronauts actually here weren't killed until impact. They were actually in contact with ground control all the way down. Now, from a height of, I think as they said, 9 nautical miles, if it was in vacuum, it'd take you about 1 minute to hit the ground. But because of air resistance on the way down, it would have taken several minutes, and they were in contact. Several of them were in contact with ground during their contingency procedures. So they weren't actually killed until impact with the surface of the water. So that was actually kept from the public at the time, and the only reason I got to find out that was a bit of inside information. So you have to take what people tell you with a little bit of salt, that it may not necessarily be right. Now, of course, those bits and pieces that came down, NASA's only ever found about 47% of the debris from the Space Shuttle Challenger, and that was over a period of many, many years, and it's actually housed inside an old Minuteman missile silo that's pretty close to the launch site, and is obviously a decommissioned Minuteman missile silo. So that particular piece, the last piece was found quite a while ago, but very recently a large piece has come to light. Just by chance, a Bermuda Triangle documentary, which is about to go public in about a week's time. Stumbled across one of the largest pieces. They were, yes. They were actually looking for a group of 5 aircraft that went missing in the Bermuda Triangle. And this didn't actually land in the Bermuda Triangle, but it was a case of they were looking outside and they found it as a direct result of this documentary. And they realised what it was. And you'll see that in a moment.
Yeah, they're wearing away. They're sitting on top of the orange tile. They're kind of loose now. Probably why there's only a couple of them. The rest of them wore away. Tiles under the tiles too. Look at these rivets. They're like smooth. This part's probably been exposed for the longest time. So much more of this goes under the sand here. So what do you think this is, Jim? Definitely an aircraft. I think we need to talk to NASA.
And indeed they did talk to NASA, and it was confirmed that it was a piece of the belly of Challenger, and all the pieces that are found actually do remain the property of the United States government, so they'll go and claim it and store it in the missile silo with the other pieces that they've found to date. So there's still a few more pieces to go. Now there's also a new landing method that NASA's been testing for use on Mars, and this shows it in a couple of minutes.
Glass looks good. Yeah. No cracks on the screen. Seems okay.
Now, would you want to be one of those astronauts on that technique of coming down? Could be a rather sudden stop. Absolutely. And of course, from today, if you missed it, this goes for about a minute.
Hydrogen burn-off igniters initiate. 7, 6, 5. 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. SLS now traveling 607 miles per hour.
And of course that thing's the size of quite a tall building, and up to 600 miles per hour, so getting on for 1,000 kilometres an hour in just a minute. And it was only a couple of minutes before they'd actually managed to insert it into Earth orbit, so goes pretty quickly. That one of course is unmanned, the next ones won't be. So they hopefully get all the bugs out of the system this time. And of course the other thing during the month was the Ig Nobel Prizes were announced. Most people are familiar with the Nobel Prizes, but there is a parody one called the Ig Nobels. And this particular year the winners incidentally get $10 trillion in Zimbabwe dollars, which I don't know what that translates to, but it's probably pretty worthless. And the winner of the physics prize is Frank Fish et al. And a few others who looked at ducklings. And we'll explain all about why they got the prize.
You're not doing science if you're not having fun.
You may probably think the ducklings are following the mother duck in a single fine line in our daily life. Why are they doing so? We try to find the reasons behind this phenomenon.
We calculated the wave resistance on ducklings when swimming in formation. We found when a duckling swims at a certain sweep point behind their mother, the mother duck's waves help to propel the ducklings forward. The ducklings are serving the waves generated by their mother to save energy. Most surprisingly, we found that this wave riding benefit could be sustained by the rest of the ducklings when swimming in single file. Each duckling behaves as a wave passer, passing the wave energy to the trailing one. The first 2 ducklings, right behind the mother duck, receive the best pushing force. From the 3rd ducklings in the queue, each individual saves the same amount of energy regardless of group size. It seems likely then the wave riding and wave passing are the principal reasons that waterfalls swim in this way.
So you see in the diagram here the energy imparted to the duckling behind. The best one is immediately behind the mother, then the next one is a little bit less, and then the remaining ones all are at the same level. And you'd have to say, why have these scientists actually looked at ducklings? And that's number one, one of the reasons that they were awarded the Ig Nobel Prize for the year. It is also to look at the possibility of convoys of ships travelling at fixed distances apart, so that the ship in the front effectively pulls all the other ones along behind it if you get them at just the right distance apart. So tonight, welcome any new members to the Society. As usual, I'll go through the events, past and coming months, then I'll hand over to Mark for Sky for the Month, and Chris will give a new segment on Monthly Photo Challenge. Then we'll look at how sunlight affects our bodies and minds. Now this is a talk that was given by at the Royal Institution in London a couple of years ago. Then we'll look at sunscreen and UV and the world's largest camera lens up close, how they made it and what it's being used for. And then we'll close with some video from NASA that they've just released. So recent events at the Society. We had the TLD here at the Briars on the 22nd, which unfortunately had a lot of cloud. Committee meeting held here a couple of days later. Then the scouts were here at the Briars. They got a little bit of opening in the clouds, so they got to see the main planets in the sky. Unfortunately, we had Frankston Hospital ICU cancel at the last moment, but it was very cloudy that night anyway, so they wouldn't have seen anything in the sky, even if they'd come to listen to me talking. 4th of November, the public night went very well. Guido gave the talk. I think he's already left. And they got to see everything in the sky all evening, so they were very, very happy about that. Then on the 8th of November, we had the lunar eclipse, and you can see my photographic effort up on the top right-hand side with my iPhone. And you can see the similarity to NASA's picture of the moon on the night. And there's Mare Crisium just there, which is that one over there, if you can't actually make it out from the image, but you can see it's circular and has dark and light areas. I'm sure there is some better coming. Over here we had a bit of water here in the Briars. You can probably see it's a bit damp at the front here, and this was all underwater at the front here the other day. Fortunately, one of our members who lives nearby kindly rushed up with a mop in hand the next day and was trying to air things out. We also had a fair amount of water down in the observatory as well, and I think the roof of the observatory is still open, isn't it, to let a bit of air in. It was sort of earlier. And there's the storm front passing through. It dumped about 80 millimetres of rain in a 24-hour period, but most of that probably came in a very short period of time, and that's why we had something in here. Now, we've never had water actually incursion into here before. And over on the left here, the Chinese have been at it again. They put up another one of their Long March rockets. If you remember, the last one came down uncontrolled and caused everyone a bit of consternation across the world as to where it was going to land, and even Spain was cancelling all flights. They grounded all flights at the time when it was coming down, just in case it caused problems there. This time, just a day or so ago, they successfully launched a satellite into orbit, about 600 kilometres up, so higher than the International Space Station, and then unfortunately the rocket vehicle blew up. Now, whether that was an accidental blow-up or an intentional blow-up, it blew the thing into about 50 pieces. It was picked up by an amateur astronomer in Amsterdam, and that's how they know how many pieces that were visible. And those large pieces are going to stay in orbit for several years, at least a decade, before they come down, because it's higher up than the International Space Station. So they're whizzing around the Earth at about once every 90-95 minutes, and will just add to the space junk that's up there. And these obviously would be very large space junks, bits of space junk. Now the problem is these Long March rockets, China's about to launch a lot of them, because they're going to put a constellation of satellites up, much like the Elon Musk ones, but using this same one again. So hopefully it's not going to continue blowing up, because if it gets to a certain point where there's too much debris up there, it's something called the Kessler syndrome, whereby you're not going to be able to launch anything into space until that debris comes down, and that could even be centuries for that to occur. So coming soon, we've got a viewing night at Camp Mannion tomorrow night, where we've got some Year 6s coming there. So I think we should have just about enough telescopes for that now. Working Bee this coming Saturday, I think, is still on as far as I know. Then on Sunday, we're going to be all day at the Bentley Street Festival, and simultaneously down at Rosebud at the Radio Fest. I think Jamie and David are going down there, whereas several of the others of us are going up to Bentley instead, or we'll be set up there all day long. Hopefully it's going to be clear for looking at the moon and looking at the sun during the day as well, while we're up there. Committee meeting coming up, then we've got a series of public viewing nights and the members' Christmas dinner. If you haven't booked into the members' Christmas dinner, remember it's free, but you have to book online and pay a deposit. If you turn up, you get your deposit back, but if you don't turn up, then it goes towards paying for everybody else's Christmas dinner. So do hurry and book with that, so we know how much roast to actually order for that particular one. In January we are going to have 4 public nights again, but we'll go the first Friday and the first Saturday of the month, then the next Friday afterwards, and there'll be actually a third Friday not shown here for the next meeting. And as announced last time, we'll have a field trip up to the Melbourne Exhibition Centre again for Brian Green. I think we've got 17 members signed up for going to that one.
Okay, sky for the month for November. Really unusual to be up here at this this early in the meeting. So moving right along. Main events to watch for over November and December. The moon. Ignore the total lunar eclipse. That's just a cut and paste error. That was last month. But the 8th to the 12th we'll have a full moon again, but it won't be eclipsed. And the new moon is on the 24th of the 11th. Things happening this month. We've actually got a few meteor showers occurring this month, but I'll do more about them a little bit later on. Comet Pan-STARRS is still about 6 magnitude, moving through Ara and Norma in the southern hemisphere there. So at 6 magnitude, it's a fairly good one for people to have a look for. And on the 8th to the 12th, Mars is finally at opposition, so the next few months you should be able to have a look at Mars, although apparently it's a bit further away. It's not one of the best oppositions because it's kind of out towards its aphelion. So the sky for the month, we're pretty well saying goodbye to Sagittarius and Scorpio now, which are the 2 constellations I tend to use during winter to try and find my way around the sky. But we do have Orion starting to make an appearance, obviously with the Orion Nebula. Very easy target, particularly for new people with their scopes, and quite visible through even an average or small size scope. Additionally, still have 47 Tucana globular cluster. It's still fairly high in the sky, pretty much above and to the west that way of the South Celestial Pole. So reasonably easy to find. And as the world turns, if you want to hang around till the morning, when all of this actually would move up into the sky a little bit, you be able to get Eta Carina again. And to the north, I think the best feature of the northern sky there is the Andromeda Galaxy. If you can find yourself a really good northern view with nice dark skies, so away from the city, you should be able to see the galaxy. Now I think, was it Chris, or was it you? It was one of you two I thought went and saw it recently, and you said it was it? It was, yeah. Is it visible to the naked eye? And no. All right, so there you go. Fairly easy to find though. It's pretty well just above the northern horizon. So out there, it's just sort of skimming across the sky. So get it at the right time, should be able to see it. Oh, it's sort of been there. You're probably looking at around about 3 months, but obviously at the start, this is your eastern sky here, so it sort of starts to come into view, and then move through there. Now each night it'll move further and further towards the west. So at the moment, November, it's probably just past the ideal spot, which is directly north. But it's still far enough above the horizon. If you can get a good northern horizon perspective, you should be able to find it quite easily. These stars here, which are the great square of Pegasus, are really obvious when you look to the north. You can actually see them from here, from the Briars, but from here the actual galaxy itself is sort of behind the trees. So get Benny to mow them all down for us. The planets, Mercury moved in superior conjunction a few days ago. Essentially means it's on the direct opposite side of the Sun to where we are. By all accounts, it actually, because of where it is in its orbit, the planets essentially stay with the ecliptic plane, but sometimes they'll go above it and below it. And apparently, if you had really special equipment, that you would have been able to film it skimming the top of the Sun. So it was an occultation. But as I said, you'd need fairly specialist equipment to have any hope of getting a picture of it. It's a fairly fast-moving planet. It only takes 22 days to go a quarter of the way through its orbit, so it won't be very long, and probably early next month it will pop up in the western horizon, or on the horizon there, and it will be fairly close to Venus. Now, Venus has already gone through superior conjunction, so both those planets, our inner planets, are essentially on the far side of the Sun, but they will pop up, and as they pop up, they'll come up in the evening sky. It's just the way their orbit works. And it says sort of the end of the month, but I reckon early December you'll start to see Venus, and Mercury should be just around there, very close to it as well. So the beauty of that is next month you should be able to do an 8-planet tour. They'll all be visible. As I said, Venus just gone through superior conjunction. Not as fast as Mercury. It takes a little bit longer before it will get up. Actually, it went into superior conjunction before Mercury, but Mercury just whizzed by it. You know, disrespectful little planet, really. Earth is moving to the part of the orbit when the South Pole actually tilts towards the Sun, thus giving us a summer. I just wish someone would tell the Earth. Okay, we also, during our summer, we approach perihelion, which is the closest approach of Earth to the Sun, which is why our summers are so much hotter than the Northern Hemisphere. Of course, if we didn't have so much rain. For the other planets, Mars is rising late evening in the eastern sky. It's just below the High Age star cluster in Taurus. The High Age is not that easy to find, although it's just above the brightest star in Taurus. And Mars is probably a little bit below. It's rather interesting because the bright, I can't think of its name off the top of my head, but it's a reddish star as well. So you're going to have red Mars and a red star as well, fairly close to each other. It reaches opposition in early December, though they reckon it's not going to be one of the best ones. But if it's a little further out, it might stop the Sun from overheating it, and so we won't get the dust storms that seem to characterise it when it's at perihelion, and kicks up and stirs up the atmosphere a fair bit, and all you can see is just a hazy planet. If the dust storms stay away, you can actually, reasonable-sized telescope, you can see details and even some of the poles, particularly in the northern one. Jupiter, visible in the northern evening sky near the circlet of Pisces. We really don't need to say much about that. It's the bright one up there. It's very easy to pick out, one of the brightest objects in the sky. That and some of the other, particularly Saturn, can help you pick where the ecliptic plane happens to be going, and most of the planets and even the Moon will follow that ecliptic plane from east to west. So if you look along there, you can pretty well find all of them. Okay, Saturn, it's a little ahead of, a little further west than what Jupiter is. It's still in a fairly good position to have a look. And a few days ago it passed its eastern quadrature. Now that essentially is a point when it's in space which it forms a 90-degree angle between the Earth, the Sun and the planet. And the advantage of that is because the light from the planet, or the Sun, is actually hitting the planet to the side, it casts a really good shadow onto the rings, at the back of the rings, and it tends to give you a bit of a 3D effect because it kind of enhances the planet and its relationship to the rings. So good position to have a look, maybe through something like the Mead at the moment, and you'll get a fairly good view of Saturn and hopefully good contrasting. Uranus can be found in Aries. It's just risen or rising in the east now just after sunset. It's just past opposition, and apparently it's about 5.6 magnitude. So anyone under 20 should be able to see it with a naked eye. Anyone between 20 and 40 might be able to see it with a naked eye, and everyone over 40 use a telescope. Okay, it really needs good seeing conditions to see something at around about 5.6 magnitude, because that is about the limit of the human eye. Apparently during the eclipse, it was within 1 degree of the moon, just off to the western side of the moon. I wish I knew that at the eclipse. I might have tried a photo of it. Actually, I did check my photos, but I didn't get far enough away, so missed out. So, yes, that would have been quite an interesting little picture opportunity there. Particularly with the moon being eclipsed, it wouldn't have outshone it. And last of all, Neptune. It's about 6 degrees west of Jupiter in Aquarius. Its proximity to Jupiter should help you find it, but it really is, even through a reasonable sized telescope, it's just a blue dot. So if you're lucky, you might be able to pick out the blue of it. Certainly can do it in photographs and that sort of stuff, but it's fairly close to Jupiter, so you've got fairly bright Jupiter, and just along the ecliptic, about 6 degrees, which is about 12 thumbs wide. Your thumb's about half a degree wide, so 12 of those, and you should be able to find, or have a shot at finding, Neptune. So appearance of the planets, you're seeing the full face of Venus and Mercury, and that's because they're on the other side of the Sun. The full face is actually lit. As they come around towards inferior conjunction, we start seeing the back of them, and so we get a crescent appearance, the same as what we get with the Moon. Doesn't mean you can see them, but if you could, you'd see the full face. Mars getting much bigger. You can start to see it does have a little bit of shadow, but not a great deal. And hopefully, as I said, we get a few more details. And for those who've been watching this for the last couple of months, you'll notice Mars's orb's a lot bigger than it was, and that's because it's approaching opposition, which is its closest approach to us. Saturn and Jupiter, always spectacular. You can find them and see the details of them fairly easily. Uranus, usually a greenish blue disk. There's not a lot of surface detail on Uranus to look at. Very hard to tell. It is actually rotating in excess of 90 degrees on its axis, so it virtually rolls around its orbit on its side. Okay, the other stuff, comets, the only one really up at the moment is Pan-STARRS. It begins the month in Norma, and it continues towards the South Pole, or South Celestial Pole. It's only visible until about 10 PM, and because of the distance, how far south it is, it will also pop up in the morning, but about an hour before dawn. So, for the really keen. It's around 6 magnitude, so as far as comets go, quite bright. Now, meteor showers, we've got quite a few, or relatively few, happening at the moment. We've got the northern Taurids. Last month we had the southern Taurids, and essentially they're associated with Comet Encke. As the Earth passes through Encke's tail, we start getting these. They tend to be fairly bright but slow-moving meteors, and the occasional fireball, although not a lot. Most of these showers are best viewed late in the evening until dawn, and maybe one day I'll explain. Now, I did actually have a slide on here one day, but essentially the dawn side of the Earth is the side the Earth is actually heading towards as it flies through its orbit, and so we run into meteors, whereas our evening side is on the back side of the planet, and so we're running away from anything. And we're travelling at 67,000 miles an hour, so pretty hard to catch us. Okay, they're from the 20th to the 10th to the 10th to the 12th, so a fairly long shower, peaking on the 12th, so they've already peaked, but that doesn't really matter. You should be able to find them, and you want to see them look in the direction of Taurus. The Leonids, visible from the 6th to the 11th to the 30th, 11th peaking around the 18th, which I think is about 2 or 3 days' time, 2 days' time. Best viewed in the early morning, mainly because that's when Leo is up, and they come from Leo, and they're associated with comet Tempel-Tuttle. You see a lot of our meteor showers seem to be associated with comets, and that's because as they travel through their orbit, they leave a trail of comets, of potential meteors. And the last one is the Alpha Monocerotids. Guess how many times I practiced that. Alright, it's only a minor shower from the 15th to the 25th to the 11th, with a max on the 21st, visible from late evening till dawn. And from what I understand, there are only about 15 meteors per hour around the maximum time, and they're just a stock standard flash and dash. So just a reminder too, Peter's already done it earlier, members barbecue and working bee, Saturday 19th, so next Saturday, starting at 4 PM, just a general tidy up, depending on the weather as to whether the lawns get mowed or not, but sweep in here. We did have some water in here during the week, so it might just be a general spruce up. Bring a salad or swell. At 6 o'clock we had the members barbecue, and if you want to put your hand up to cook the snags, feel free. It's always a good spot. If you're at the barbecue, everyone comes up and talks to you. You're trying to concentrate on cooking the snags, and they're all talking to you. Meet other members, and if we do happen to have a clear night, we generally open the observatory and put the scopes on various objects. So it's a good opportunity for newer members to, one, get to know people, and two, get to have a play with the telescopes. And on Saturday the 17th of December, starting around 5 PM, we have the MPAS Christmas dinner. It's our annual dinner. It's a catered event, so no one has to cook. You will need to book for it though, so that we know how many people to cater for. Alrighty. Tonight's information provided by Astronomy 2022 from Wallace Dawson Northfield. Thank you.
Hey, I'm Chris, and this is something new that we're going to try. Monthly Astro Photography Challenge, or AstroMofo. Alright, now the idea of this is to have a monthly challenge for members where we select an object in the sky, and then members are tasked with getting a photo of it. We learn a bit about the object, and people can also learn a little bit about using their equipment and taking a few photos. As this is the first one, we don't have an object to discuss last week, but for last month, but if we did, it would have been the moon, and probably in particular the lunar eclipse. As it happens, I got that. So that's the moon just before it comes out of the Earth shadow, out of the umbra, taken by myself. That was just here at the Briars during the lunar eclipse night. I do also have a couple of other photos from some other members. I got this one here from Anders Hamilton, sent me a couple of beautiful pics that he took, and also Mark Stevens. Thanks, Mark. Sent a couple of nice photos at different stages of the eclipse, as it's in the umbra and as it's going into and coming out of the shadow. So some nice shots there. And also, as you may have seen, that I had my equipment set up here. I was taking a few shots. I took a shot every 30 seconds of the eclipse during the course of the night, and I managed to put together a bit of a time lapse. So I'll just put that for you. It just goes for about 30 seconds or so. Not playing. Play. No. Play. Doesn't want to play. Almost? Unfortunately, it doesn't want to play. Hang on. Nope. Sorry about that. It was doing it earlier. Here we go. Okay. So this is captured through most of the night. You can see a star popping in behind the moon over there. There's a bit of an occultation. The first section of it went for around about 23 minutes. The middle section, while it was in the umbra, was for about 93 minutes. And this bit of it here coming out of the shadow lasted around about 64 minutes or so. With the first frame I got was around about 8:49. The last one was at about 11:55. Okay, so the monthly photography challenge. Basically, as I was saying, it's a photo challenge for MPAS members, and it's open to first-timers and old-timers, or more experienced photographers. I'd really like to see people who haven't taken a photo get their equipment out and start taking some shots and just sharing them and learning about them, and also learning about the objects that we're looking at. And the object of the month will be announced at the members' meetings and on the MPAS socials. It is compulsory, and if you don't submit photos, you cancel your membership and you are banned from attending the Briars. Is that right? No? Optional. It's optional. You can participate or not. Use whatever equipment you've got at your disposal: a smartphone, a DSLR, telescope, or a box brownie if you've got one. And basically, your photos can be single shots, stacked, processed, tracked, tripod, whatever you can do. Just get started and get snapping. But it must be a new photo that's taken after the target is announced. So if we, for example, say 47 Tucana, Mark, you can't just pull out a photo from last year and say, oh, I got that one. So the idea is to get a new photo of it from that month, and we just share the photos then. Photos should be submitted, the Friday prior to the next members meeting, so that I can include them and maybe say something about them. And the photos won't be judged, we'll only applaud them. So basically what you get out of it is we share some photos, share some techniques, learn about the objects, and it'll also give you more photos on your phone, so you can share your friends and family and strangers at parties, even though they didn't ask to see them. Okay, when you put the photos in, just put some information about it: your name, the object name, where you've taken it, backyard, etc. And the method, just a little, share some information. Also helps you see how photos that you see were taken. And submit the photos to the socials, or eScorpius, or to my email. Okay, now this month's object that I've picked is the Large Magellanic Cloud. Situated south, at this time it's around about 30 degrees up in the sky, and it's just getting higher as the night goes on. So it's a really good time of the year to photograph it. The LMC is around about 160,000 light years away. It's a dwarf galaxy that's approaching the Milky Way, and it's the second or third closest galaxy to us, the closest one being the Sagittarius dwarf elliptical galaxy, which is almost collided with us, I think. And the next one is a questionable one. It's called the Canis Major overdensity, which is sort of debated whether or not it's actually a galaxy or not that's merging with us. So it's pretty close, and it's also the fourth largest galaxy in our local group. Milky Way, Andromeda being the largest, I think, and then Milky Way and M33, the Triangulum, being the next ones. Now, the Large Magellanic Cloud is a Magellanic spiral, so called because they have the characteristic of having a single spiral arm, and all Magellanic spirals are named after the Large Magellanic Cloud being the first of its type that was observed. Thank you, Wikipedia. You can actually see it from dark sites. It's visible to the naked eye, even here at the Briars. When it gets dark and your eyes adjust, you can see it up in the sky. Okay, where are we? Now, just a couple of fields of view. If you were going to photograph this just with a DSLR at around about 100 mil, can you make out that red square on the screen? So that's the field of view from a DSLR at about 100 millimeters focal length. If you go shorter focal length, you'll get a wider field of view. Longer focal length, it'll narrow your field of view. Also be wary, and you'll see for yourselves, as you increase your focal length, you'll decrease the amount of time that you can keep the shutter open. If you're not tracking it, you'll get star streaking and so forth, but you'll figure that out. From a ED80, an 80mm telescope with about a 500mm focal length, you'll get a nice shot of the Tarantula Nebula, which is quite famous in the Large Magellanic Cloud, and it's a pretty good one to shoot for beginners as well. It's a pretty easy one to photograph. A larger telescope, say like the Newtonian in the observatory, you might be able to get some of the fainter objects, some of the smaller objects to photograph in there as well. Some star clusters, some star fields and so forth. And there's no shortage of targets in that area, so there's all sorts of things that you could aim for with a larger telescope. Okay, now I'd like to see, I'm guessing beginners will probably go for maybe a wide field view, or maybe get the Tarantula. If you're more experienced, maybe try get something, one of the smaller objects that's in there. And that's it. Now, I'll be at the members barbecue, so if anyone wants to bring some equipment and have a go at it, I'm happy to share my limited knowledge and try and get you started if you like. And yeah, hopefully we'll get some shots and information to share for the next meeting. Thank you very much.
Tonight's feature, which goes for about 50-55 minutes, so any time during that, please feel free to get up quietly and go out and have a cup of tea out the back as well, as we've shuffled around the order tonight of the order that we do these things. Linda Geddes here is a cell biologist, talking about the effects of sunlight and how they affect our bodies and minds, and this was given in the Royal Institution in Albemarle Street in London, and co-sponsored by University of the Third Age, and you'll see why a little bit later.
Thank you. Hi, can everyone hear me? Good, I wasn't sure if my microphone was switched on. Thank you very much for coming. So I'm going to be talking about the effect of light on our minds and our bodies. I'll just check, yeah, we're okay, good. So if you ever need a reminder of the awesome power of the sun, the Mojave Desert in the southwest US state of Nevada is a very good place to start. In summertime, the daytime temperature frequently hits 49 degrees centigrade, and stepping outside is literally like walking into a giant furnace. The local flora and fauna arm themselves against this intense heat. Joshua trees grow these tough concave spikes for leaves, channeling what little water does fall down towards their roots. Animals like rattlesnakes and coyotes only emerge after dark or at dawn and dusk, so they're crepuscular. And then you have desert tortoises that burrow down into the sand to escape the whole summer. Humans are less well equipped. So just to the south of this desert is the Sonora Desert. And every year, hundreds of Mexican and Latin American migrants meet their deaths while trying to cross into the US. The sun strips away their body fluids and causes them to overheat. Our ancestors revered the sun as this creator and destroyer of life. Just to the east of this desert is Chaco Canyon, where Native American Indians constructed this kind of calendar where it consists of these three giant rock slabs. And at kind of key turning points of the year, so in particular the winter solstice and the summer solstice, you get sunlight penetrating down in the cracks between these rock slabs and alighting on this kind of pecked solar imagery. to kind of tell the time of year. And this similar imagery of light penetrating the darkness at key turning points of the year is found all over the world in civilizations thousands of miles and indeed years apart, from Machu Picchu in Peru to Stonehenge in southern England and Newgrange in Ireland. So our ancestors, the ancestors revered this relationship with the sun, but today we've largely lost this connection. This is Las Vegas, also rising out of that desert landscape, as if in defiance. At night, the Las Vegas Strip is the brightest place on Earth, and the brightest source of artificial light on the planet, in fact, emanates from the tip of the Luxor Resort and Casino, which is this vast pyramid-shaped building which issues this beam up into the sky called the sky beam each night. Local aeroplane pilots are kind of forewarned of this because it can kind of throw them off. But you can see it if you fly over the desert at night, you can see this beam of light. It's almost like it's issuing this direct challenge to the sun. Because Las Vegas has tipped our traditional relationship with light and dark on its head, and it's an extreme example of what we do every day of our lives in the modern world. So about 15 years ago, I found myself in this muddled up place, Las Vegas, while covering a conference for Las Vegas. It didn't have anything to do with sun. It was a forensic science conference. And I was kind of riddled with jet lag, having flown over there, and spent several days just locked indoors in this windowless meeting room in this small business hotel. And by the end of this, I was just desperate to find somewhere to sit outside and have a cup of coffee in the sun, because it was October and it wasn't it was hot, but it was that kind of beautiful, dry, crisp heat, and the sun, the sun was out there were no clouds, and yet there was nowhere to sit outside. So, the casino owners in Las Vegas have kind of recognized that the sun has this phenomenal influence over our body. It enables us, for one thing, to keep time. And the last thing you want if you're a casino owner is for people to know what time it is. They've also realized that actually light and different colors of light can affect our psychology. So, for instance, studies have shown that if you pair red light with fast music, people will bet faster and they'll take bigger risks with their money. So as I found myself just walking through these endless kind of chains of underground shopping centres, just trying to find somewhere to sit outside. And it was really, really, really difficult. Until I got to the resort of Caesar's Palace, which is this. Has anyone ever been to Las Vegas? Have you been to Caesar's Palace? So, anyone who hasn't been there, Caesar's Palace is this, kind of fantastic mock Greco-Roman empire, mostly underground. It's extremely impressive. And as I was kind of walking through there, kind of stumbling moth-like after these days of being shut indoors and my night times out on these casino floors having fun, I saw what I thought was sunlight up ahead, and I got very excited. I was like, finally, my search has come to an end. I can sit down and have that cup of coffee and enjoy the sun. And I got there, and I looked up, and what I saw was not the real sky. It was this vast, really beautiful artificial sky. And as I kind of slumped, defeated, next to this replica of Rome's Trevi Fountain, it just kind of struck me how perverted our relationship with light and dark has become in the modern world. As I said, I was working at New Scientist at this time, and I'd been writing a lot about these things called circadian rhythms, which I'll come to later, but they're these 24-hour fluctuations in the activity of pretty much every biological process, from the most obvious one being when we feel sleepy and alert, but then it also controls things like our brain chemistry, our mood, when we release hormones, the activity of our immune cells. So, for instance, our response to the flu vaccine is different. It's more potent if you get the flu vaccine in the morning compared to the afternoon or the evening. And the same year, I think, that I was in Las Vegas, the International Agency for Research on Cancer had just designated shift work which interferes with these circadian rhythms and introduces people to this very different pattern of light and dark. So you're seeing a lot of light at night and a lot of darkness in the daytime. It just said that shift work was a probable human carcinogen. So I was becoming very interested in this whole thing. Because circadian rhythms aside, our biology is set up to work in partnership with the sun and this 24-hour cycle of light and dark that we humans, and in fact all organisms, evolved under. Our ancient ancestors didn't only revere the sun from a spiritual perspective, constructing these vast monuments to mark the solstices and the turning points in the year. They also revered the sun from a kind of health point of view. So the ancient Egyptians and Babylonians recognized that the sun had these healing properties. They would, particularly for skin diseases, they'd anoint the skin in various herbal balms and combinations and expose it to the sun. The Ebers Papyrus, which was an ancient Egyptian medical document, talks about how you can relieve pain by exposing the skin to sunlight and warm sunlight. This extended to the Greeks and Romans as well. I mean, they kind of built these solaria and advocated sunbathing, actually, as a remedy for all sorts of things, from malnutrition to obesity to asthma. The ancient Greek physician Hippocrates was an advocate of sunbathing, but he was also actually the first person to discover this thing, melanoma, this deadly skin cancer. And he's also famous for kind of advocating everything in moderation. Hippocrates was actually the first person to document a circadian rhythm in humans. So he noticed that the severity of fever kind of waxed and waned over the course of 24 hours. So, you know, people's fever would get worse and then better, and then worse and then better again. And he also recognized that human biology seems to differ slightly according to the seasons. But this interest in light had a kind of a resurrection in the 19th century. So this is Florence Nightingale, who wrote in her notes on nursing that it's the unqualified result of all my experience with the sick, that second only of their need for fresh air is their need for light. And that after a close room, what hurts most is a dark room. And it's not only light, but sunlight that they want. So Nightingale noticed actually how these patients in these hospital wards, she was caring for sick soldiers, they would quite often turn their bodies to face wherever the window was, even if lying on that side of their body was painful for them. It was almost like humans have this they're kind of light seeking, and they are looking for that light source. Because as I said, our biology is set up to work with sunlight, actually. So most people would be familiar with vitamin D and the fact that we produce vitamin D when we're exposed to sunlight, but the sun does other things to us. So not long after Florence Nightingale was advocating for sun exposure in hospitals, there was a Danish doctor called Niels Finsen who won the Nobel Prize for his work on showing that light could cure tuberculosis of the skin. So the sun has these bactericidal effects. It kills organisms directly. But then there's the vitamin D story. So by the 1920s, in fact, they were kind of starting to get to grips with the fact that sunlight causes vitamin D production. But at the same time, people were being sent off to these sanatoria to cure things like bone tuberculosis and lung tuberculosis. And we now know that the reason that sunlight therapy worked is that because when we produce vitamin D, it doesn't only strengthen our bones and our teeth, which is what most people associate vitamin D with. It also works with our immune cells. So we have these immune cells that kind of travel all over our bodies, but in the lungs, when they encounter pathogens like the bacterium that causes tuberculosis, they use vitamin D to start spewing out this antimicrobial compound called cathelicidin. So it's not only kind of UV light from sunlight isn't only killing the bacteria on our skin, it's helping our immune cells kill bacteria as well. But the sun does other things to our skin as well. So we have to worry, we do genuinely, Sorry, I'm losing my chain of thoughts. Obviously, too much sun exposure results in the development of skin cancers and that deadly skin cancer, melanoma. And the reason it does this is because UV light triggers our DNA to mutate. And if those mutations go unchecked, then they can develop into cancer. But another reason why the sunlight can be so harmful is because it suppresses the activity of our immune cells. And our immune cells are another way of catching and destroying cancer. So if you get those UV mutations, and then usually your immune cells will recognize these dodgy cells and kill them. But if that activity of those immune cells is being suppressed by too much sun, then they're not so good at spotting those abnormal cells in the first place. But actually, scientists are starting to think now that a bit of sun exposure may be beneficial for our immune systems, and it may actually have evolved as a way of keeping our immune system in check. So there's, one disease which is more prevalent at high latitudes, so the further north or south you go, is multiple sclerosis, which is an autoimmune disease. And they're starting to think that if you don't get enough sun exposure, that might cause the immune system to be more likely to kind of spiral out of control and start attacking self, which is what happens in multiple sclerosis. And then there's another interesting thing, which is that when we're exposed to sunlight, we get a drop in our blood pressure. So people's blood pressure tends to be lower in summer than in winter. And the reason for this is that when we're exposed to sunlight, we release this substance in our skin called nitric oxide, which causes our blood vessels to relax and get wider. So then you get this drop in blood pressure. So there's a dermatologist at the University of Edinburgh called Richard Weller, who recently discovered that being exposed to the equivalent of about 20 minutes of British summer sunlight causes a drop in blood pressure, which is enough to be clinically significant, and it's maintained for up to an hour after we step indoors. But as I said, it's not only the skin, and the rest of this talk I'm going to be focusing on these things called circadian rhythms. So at the back of the eye, on our retina, behind the rods and cone cells that enable us to perceive colour and black and white and to see, you have this other subset of cells. They have a very long name. They're called intrinsically photoreceptive retinal ganglion cells, which is a bit of a mouthful. So from now on, I'm just going to refer to them as light-sensitive cells, but what I'm talking about are these IPRGCs. And these cells are particularly responsive to light in the blue part of the spectrum. They'll respond to any light if it's bright enough, but particularly this blue spectrum light, which we find in many light sources, actually. So you get lots of blue light in daylight, even though, daylight is composed of light from across the spectrum, but it has blue in there, and sunlight is very bright. So these IPRGCs, or these light-sensitive cells, are very responsive to daylight. But another source of light that contains a lot of blue is the new LED bulbs that you find in ceiling lights and electronic screens. So many of you may have read newspaper headlines or heard news reports recently about having to avoid blue light at night because it interferes with sleep, and I'll go into that in a bit more detail in a bit. But these light-responsive cells in the back of the eye do a few things. They plug into areas of the brain which influence our alertness. So exposure to bright light, like I'm getting in my eyes right now, literally wakes you up. It's like drinking, actually. Being exposed to even quite low-intensity blue light for an hour is equivalent to having several cups of coffee in terms of the boost in alertness that you get. Those light-sensitive cells also feed into areas of the brain that regulate mood. And we know that actually, in the case of things like seasonal depression, that exposure to bright light in the morning has a strong influence on mood. It's an antidepressant. But the other thing these light-sensitive cells do is they directly connect to our master clock in our brain. It's a very, very small area of brain tissue, about the size of a grain of rice, that acts kind of like the body's Greenwich meridian. So in every cell of our body, we have these molecular clocks ticking away, driving these circadian rhythms. they actually will tick away in the absence of light. And they control all these things, as I said, from the release of hormones to all sorts of things, like even our grip strength varies over the course of the day, our body temperature, our alertness, our bowel movements. And in some people, these molecular rhythms are ticking away at slightly under 24 hours, so 23 and a half hours. These people tend to be larks. In other people, they're kind of more like 24 and a half, closer to 25 hours, and those people tend to be night owls. But even though we have these genetically predisposed kind of preferences to when we sleep and wake up, all of us manage to stay synchronized to the 24-hour day here on Earth. So how do we do that when our rhythms are kind of closer to 23 hours in some people and closer to 25 in others? Well, the way we do it is by the impact of bright light falling on those light-sensitive cells at the back of the eye. It basically acts as a kind of reset button on a stopwatch each day. So it tweaks the timing of our clocks in our master clock in the brain. And that then sends signals to all these other clocks, which is how it functions as a Greenwich meridian. It keeps them all synchronized with each other and with what's going on in the world around us. And it enables us to predict regular events in our environment, historically and through our evolutionary history, when predators are going to be out about, when it would be a good time for us to knuckle down and hide in a cave, and when it's a good time to be out seeking food. Sorry. There we go. So, but in the modern world, things have been altered. So that clock, light exposure will act as a reset button, but depending on when we see light, it can push the timing of those clocks forwards or backwards. So light at night tends to shift people later. And as I said earlier, many of you may have heard about these kind of detrimental effects of looking at tablets or smartphones in the run-up to bed. And several studies have shown that using these things in the run-up to bed can impact the quality of your sleep. So you tend to get less deep sleep, and your sleep also seems to be more fragmented. Why is that? Well, for one thing, light suppresses the release of this hormone, melatonin, which is under the strong control of the circadian clock. And melatonin basically acts as the body's signal of nighttime approaching. So we start to release it in the evening, and then it kind of ramps up overnight, and then it falls away in the morning. And it signals to the whole body that it's time to kind of switch gear and start doing the things that the body does at night. Like one of the things that it does at night is the brain seems to flush water through its tissue and flush out a lot of toxins, including beta amyloid, which is associated with Alzheimer's disease. So, it's an important marker of the night. But when you see bright light at night, even though the body's starting to release it, that bright light will suppress it. So it's almost kind of suppressing that kind of nighttime signal. And melatonin is also really important for signaling to the areas of the brain that control sleep. So it's kind of, when we see light at night, it's almost suppressing those kind of sleep signals. So, and then, as I said a minute ago, light also directly affects alertness. So if we're seeing light at night, we're feeling less sleepy. We're not getting the signal that it's time to gear down and go to bed. And we're also feeling more alert, particularly if the light is particularly bright or blue. But it's also pushing our clocks later, so it's making us more night owlish. And that doesn't necessarily matter if you can choose to get up whenever you want the next morning. But if you have to, if you have appointments to keep, if you have to go to work or school or help other people go to work or school, then it can cause your sleep to become shortened. It's also a problem because light at night can cause greater inconsistency in the timing of your sleep. So what you really want is it's really hard, and I don't do it myself, but I try to, is to go to bed at the same time every night and wake up at more or less the same time each morning. And the reason for that is that if you can move your circadian rhythms, but when you do that, that's how you adapt to jet lag and when you go abroad. But the clocks in all your different tissues don't move at the same rate. So you start to get this kind of circadian desynchrony spreading through the body, where the clocks in, say, your liver cells and your brain cells and your muscle cells are not quite in synchrony with each other. And you get this thing called, there's this phenomenon called social jet lag, which happens when people get up at different times on weekdays compared to the weekends, and you get this circadian desynchrony. And this thing called social jet lag, which you may have heard of. And in the words of a professor called Till Roneberg at the University of Munich, who came up with this term, social jet lag, the more of it you experience, he said, the fatter, dumber, grumpier, and sicker you will be. So it's important to stay regular. But the thing is, it's not just light at night that's important, because our daylight exposure also affects the magnitude of these circadian rhythms. So one thing you often find in hospital patients or care home patients is that their circadian rhythms, so these 24-hour oscillations in our biological activity, become flattened. So in a healthy person, they'll be like this at night and day. And then if you have a more even exposure to light and dark over light and day, they become kind of flattened and desynchronized. And this is important because our light environment in the daytime is also very different in the modern world compared to how it used to be. So illuminance, or brightness, is measured in this unit called lux. I took these photos and light meter readings outside I think it was in December in Bristol, where I live. And you can see, even in winter, facing towards the sun, it's about 30,000 lux outside. And facing away, with the sun behind my back, and this is in the morning, you can tell by the length of the shadows, just after I've done the school run, it's about 11,000 lux outside. This is a photo taken at dusk in the middle of the summer. So you can see kind of just before the sun goes down, it's about 500 lux outside. But indoors, it's a very different story. So this first photo is taken in the really bright light-filled atrium of the Gibbs building at the Wellcome Trust. It's a beautiful, beautiful glass front. But you step 4 meters away from that glass, and it's already dropped down to about 190 lux, which is similar to the kind of light you'd find in many office buildings, actually. The second building is a hotel room I was staying in. I'm standing right next to the window, with the window behind me looking into the room. It's about 90 lux. And then the next picture is the same room with the curtains shut, 71 lux. Before I came out just now, I took a light meter reading of the brightness in this lecture theatre, 35 lux. And, outside on a day like today, which is fairly overcast, it's still probably about 5,000 lux outside. So, like 140 times dimmer in here than it is outside. So the message from this really is that we are really spending our days in the biological equivalent of twilight, and we're also lighting up our evenings in a way that our ancestors never did. This slide is really just to show you some kind of typical light meter readings, and you can see that in the daytime, it's dim. It's dimmer than it is at sunset outdoors, and in the evenings, in a kind of standard living room, it might be sort of 30 to 70 lux. But then if you get into, the kind of bright kitchens with the bright LED lights in the ceilings or bathrooms, it can easily get up to 200 lux. And it's very different to the pattern of light exposure that we evolved under. The man we have to thank for all this is Thomas Edison. So up until the kind of early 1800s, people experienced the night the old way, and the only real source of light at night was firelight or the light produced by burning candles or whale oil lamps. The first big change was the invention of gaslight, but gaslight was still pretty dim. Even so, it did change people's relationship with the night. The word nightlife actually evolved in 1852, because suddenly you had gas lights and people could start spending their evenings window shopping, or things like cafe culture and going to the theatre. These things flourished because suddenly you didn't have to rely on dim flames anymore. But the big change came in 1879 when Edison invented the incandescent light bulb. Edison was not a fan of sleep. He once quipped that everything which decreases the sum total of man's sleep increases the sum total of man's capabilities. There's really no reason why man should go to bed at all. And of course, electric light has enabled shift work to take off in a major way. Edison also said that genius is 1% inspiration and 99% perspiration. Edison was clearly a bit of a genius, but on the subject of sleep, he was wrong. Because sleep deprivation really is deadly, and it can kill us quickly or slowly. Just from a quick point of view, driving without enough sleep is deadly. So driving on 4 to 5 hours sleep has been found to quadruple your risk of crashing compared to if you get 7 hours of sleep. But over the long term as well, chronic sleep deprivation has been associated with the onset of Alzheimer's disease, cancer, psychiatric disease. It's also associated with heart disease, obesity, and diabetes. These things have also been associated with an increased risk. Shift work has also been associated with an increased risk of these things. And it doesn't just seem to be about sleep duration, but also about circadian disruption. So there was an interesting study which looked at the effect of getting 5 hours sleep per night versus 5 hours sleep per night at regular times versus 5 hours of sleep per night at irregular times, so changing that 5-hour sleep window. And they did this to a group of people over the course of 8 days, and what they found in both groups was that their sensitivity to this hormone insulin, which enables us to control our blood sugar levels, dropped, in both conditions, so when they were not getting enough sleep and when they were not getting enough sleep at different times. And levels of inflammation in their bodies also went up, and inflammation is another of these things that seems to be being linked to pretty much every chronic disease that we get. But in the irregular sleep group, so the people who were not getting enough sleep but were also not getting that sleep at different times of day, so they were getting this kind of circadian desynchrony, these things, so this decreased insulin sensitivity and this inflammation, in both of these things doubled. So it was a lot worse if you were getting not enough sleep at different times. And there was another study which looked at people who were getting enough sleep. So they were getting 8 hours of sleep per night. But again, they were shifting the timing of this sleep day by day. And in this study, they did this to 10 people over the course of 10 days, and they were kept in a sleep lab, so they didn't go outside. They would just, they could really, really finely control the kind of light exposure these people were getting. And here again, they found that people's insulin sensitivity dropped, and their ability to control their blood sugar dropped. And in 3 of these 10 people, actually, who were previously completely healthy, after just 10 days, 3 of them had developed pre-diabetes. So their blood sugar control was all over the place. So it's an indication that this stuff matters. So, what would happen if we reverted to a more traditional relationship with light? While I was researching my book, Chasing the Sun, I had the opportunity to go out to Pennsylvania in America to spend a long weekend with a group of Amish people. Now, the Amish people are interesting because the reason I was interested in them anyway was because they have a much more traditional relationship with light. So they're not allowed to connect to the electric grid, not really because they're opposed to electricity per se, but they don't like the kind of trappings of modern life that it brings, things like the internet and all that kind of bad stuff. But they do have gas lights. So their evening light exposure is, I've got this next slide shows us. So their average evening light exposure is significantly dimmer than we have in the West. This is the kitchen of the house I stayed in, and you can see that big light, that light there, it's a big kitchen because they have big families, but they just have that one gas light which lights their whole downstairs, and then it's on wheels, so that box it's standing on is a kind of wheelie box. And so they'll cook and eat by this light, and then they'll wheel it into the sitting room, and then they'll use that light to do their reading or whatever they do in the evening. This is changing though. So, traditionally the Amish would just use one gas light, and then if they needed to go to the bathroom or anywhere else in the house, they'd either use an oil lamp or they would just carry a torch, a battery-operated torch, because they're allowed to use batteries. But these, can you see over on this side, these kind of mushroom things? This is a really new thing. And this family had started using them. These are LED lanterns, and they're extremely bright and ferocious. And actually, they produce a lot of blue light. So things are changing. But on average, the Amish are exposed to far lower levels of light than we are. And then their daytime light exposure is a lot brighter. And the reason for that is, for one thing, a lot of them still do agricultural work. Whatever they do, they tend to work very close to home, and they're not allowed to drive. So they tend to walk, or they ride these giant, because they're not allowed to use bikes either, so they ride about on these giant kind of oversized push-along scooters, like kind of kids' mini micro scooters, but a kind of giant adult version with cycle wheels for the wheel. They're very, I should have put a picture up because they're really interesting. But the Amish are interesting. So I went out to spend some time with the Amish to find out a bit about how they sleep. And in common with other pre-industrial communities that have been studied, so these are people living in tribes in Africa or South America, what you find is that people tend to go to sleep earlier. They tend to go to bed not as soon as the sun sets, but earlier than we do in Britain on average. So this is also seen in the Amish. So the family I was staying with, I asked what time they typically went to bed, and they said, like 8:30 or 9 p.m. And then in the mornings, they get up at about 4:30 or 5 a.m., which was good for me because I had jet lag again. So, that was a bit of a lie-in for me. But I interviewed a lot of Amish people about this, and all of them said, Amish society kind of gets going at about 5 in the morning. But there are people who will identify as night owls, even in that society. And there was this woman called Katie Baylor who claims to be one of these night owls. So I said, so Katie, when would you like to go to bed if you could? She's like, 10 p.m., that would be great, but my husband won't let me. He wants me to go to bed. And I'm like, okay, sounds quite early to me. What about getting up? When would you like to get up? And she complained that she had to get up at 5 a.m. to cook her husband breakfast. And she said, I would love it if I could sleep in until 7 every day. That would just be perfect. So, you see this kind of this earliness in this community. So what would happen if we had this relationship in say, urban Bristol? Well, I decided to find out. So this is me 3 winters ago. I did this experiment with some sleep researchers at the University of Surrey. And we were interested in what would happen if I went cold turkey on artificial light after dark, but also if I tried to get more bright light exposure during the daytime. And the way I did with this was that after 6 p.m., it was in December, and I had to work during the day on my laptop. So I went, okay, from 6 p.m., no electric lights, and this also applied to my family, and my kids were not so happy about this. But we're just going to use candles after dark. And in the daytime, even though I have to work in an office, I'm going to do everything I can to get outdoors, little and often, really. So things like, this is me in my local park doing my Pilates, which I'd usually do in a windowless gym. And, going for a run, going for a walk around the block at lunchtime, eating outdoors, having a cup of tea in the garden in the morning rather than in my kitchen. These kind of little and often ways of getting more bright light during the daytime. And what we found, even though I was doing this in an urban city in the middle of winter, sorry, that's urban city, of course it's urban. Even though I was doing this in the middle of winter in Bristol, what we found was that my circadian rhythm, and we measured this by looking at when I started to release that nighttime hormone melatonin, my circadian rhythm shifted between an hour and a half to 2 hours earlier each day, so I became more of a lark. And I was also, I mean, it was difficult because I was doing this in the run-up to Christmas, so even though I was definitely feeling a lot sleepier in the evenings than I would normally be, we had quite a lot of social engagements, and actually we had a lot of friends and relatives who were just quite curious to see what on earth we were doing and what it's like to live without electric light in winter. And it's very nice, actually, although there are certain activities like chopping carrots and onions, which are not to be recommended. But what we found, apart from this, was that it wasn't just the cutting out of light at night that had this effect. So even I did a week where I was just trying to get out more during the daytime. And then, too, we saw this shift towards earlier timing, a more kind of larkishness, if you like. And we also found that the more of this bright light I was exposed to during the daytime, the more sleep I got. And I also felt more, the thing that really, really struck me was that when I was waking up in the morning, usually my kids come kind of bounding into the room at sort of 7:30 each morning and like, it's time to wake up. And I kind of pulled out of sleep and feel very groggy, this sleep inertia. But on the weeks when I was cutting out my light exposure at night and getting more bright light in the daytime, and especially in those bright daylight conditions, I was waking up before my kids were coming in, and I was waking up kind of refreshed and alert and kind of ready to go. And my mood was also more positive when I woke up. So I was kind of doing this whole battery of kind of sleep diaries and sleep questionnaires and alertness and mood questionnaires. But of course, that's just me, that's just an N of 1. But this has been found in other studies, larger studies as well. So the General Services Administration is like the US's biggest landlord, really. They control all the kind of office buildings that are used by the US government. And they were interested in what's the impact of getting more daylight into their offices. So they've been renovating a lot of their office buildings to put in more windows, and they wanted to know, is this actually having an effect on these office workers? Do they like it? Is it improving their sleep or anything? And so they compared office workers in some of these brightly lit buildings, the ones with lots of daylight, and then some other buildings which were more kind of conventional and dimmer inside. And on first glance, and they got these office workers to wear these light meters around their necks, so they were measuring how much light they were exposed to over the course of the day, and then looking at their sleep and their mood and all these things. And at first it was not very encouraging, actually, because even in these buildings where they'd spent vast amounts of money bringing more daylight in, once you got a few meters away from those windows, the light was tapering off quite quickly because of things like people pulling the blinds. And in the US, they're very fond of these office partitions, so these are kind of blocking the light as well. But when they compared different individuals according to how much light they were being exposed to, they saw this really interesting thing. So generally, people who were being exposed to high amounts of light during the daytime were taking less time to fall asleep at night, and they were getting more sleep. And it was particularly true of people who were seeing a lot of bright light first thing in the morning. So in this group who were seeing the most light first thing in the morning compared to the ones who were seeing the least light in the morning, it was taking them 18 minutes to fall asleep at night on average compared to 45 minutes. And they were also sleeping for, I think it was about 20, I can't read my slides, 20 minutes longer. And it wasn't just the sleep, it was also their depression scores. And some of this might have been just to do with the fact that they were getting more sleep. But there is this association with being exposed to bright light first thing in the morning and having better mood, which is one reason why it seems to work. Bright light seems to work for seasonal affective disorder. It's actually an effective treatment for general depression as well. So being exposed to, using these sad lights to treat general depression has been found to be as effective as taking antidepressant drugs. So, you know, in summary, I think all of us should be trying to spend more of our daytimes outdoors and dim our lights in the evenings. But what if you can't because you're elderly or infirm or a hospital patient? As I said earlier, hospital patients, you know, hospitals tend to be characterized by these small windows and lights which are kind of switched on overnight as well. So you get this kind of more even light-dark exposure between day and night, and you get this flattening of the circadian rhythm. And then it's made worse by the fact that certain drugs, including morphine, also interfere with the circadian clock. And there's even some evidence that, that patients recovering from major medical interventions or things like heart attacks, that the ones who are left to recover in a bright room and get a lot of daylight, they tend to get out of hospital sooner. I think the evidence is more compelling from animal studies, actually. So there was a very kind of scary study actually done in mice recently, which looked at if you simulate a heart attack in a mouse that has a disrupted circadian rhythm. So basically you give a mouse the equivalent of jet lag, and then you tie off their blood vessels to simulate a heart attack. And then you look at what happens to them over the next couple of weeks, and you compare them with mice that were getting kind of regular light-dark exposure and had normal circadian rhythms. And what you see is that those ones who had disrupted circadian rhythms, just like you see in hospital patients, they were getting more scar tissue in their hearts as a result of the simulated heart attack, and their survival rates were significantly lower. And with this in mind, some hospitals are starting to take light very seriously indeed. So Glostrup Hospital is a hospital in Copenhagen in Denmark, and they have been experimenting with this, it's called human-centric lighting or circadian lighting. But basically the idea is that you're trying to use electric lighting to simulate what's going on in the world outside. So during the daytime, you have these very bright, intense white lights to try and get it much more like daylight in the rooms. And then as afternoon progresses and evening comes on, you're kind of stripping out that blue light and making it either amber or dark overnight, unless the doctors and nurses have to come in to do kind of just regular checks, or if there's an emergency and they put the lights on. The light that comes on is this kind of amber light. It's not the kind of normal bright light that you'd get in a hospital. And they did this study in a stroke rehabilitation ward. So some of the patients who were recovering from strokes were housed in a normal hospital ward with normal hospital lighting and normal amounts of daylight coming in, and other ones were housed in this kind of human-centric lighting condition. And what they found was that the ones that were in these these light conditions, you saw this strengthening of their circadian rhythms. So it was going from that to more like this. And you saw that their levels of tiredness, and tiredness is a common kind of thing that you see in the aftermath of a stroke, they were getting less of this tiredness, especially during the daytime. And they had lower depression scores, because depression is another common thing that happens in the aftermath of stroke. The doctor who was running this study, which has now been published, said to me at the time that the effect on their depression scores was equivalent to giving them antidepressants. And in fact, you know, they often do prescribe antidepressants to these patients. And so, and for the ones who were getting antidepressants, it was even greater. And a nurse I was speaking to said that actually in the dementia patients, she noticed the effect even more. And she said they just seem to have a better idea about what time of day it is, and they're calmer. And that's interesting because dementia is another area where researchers have kind of done the most research into this idea of circadian lighting. So generally, our circadian rhythms change. Actually, our circadian rhythms change throughout our lives. So as children, we tend to be quite early, kind of larkish creatures. And then in adolescence, we shift right the other way and we become really owlish. And And then as we get older, we kind of drift back the other way. So once we get to retirement age, we're much more like little children. Which is so actually, some researchers have kind of suggested this might be one reason why we have this variation in our circadian rhythms, is what he calls the poorly sleeping grandparent hypothesis. And it's that, that as you get older, you see this distribution throughout society of different ages. And, traditionally we lived in kind of extended family groups, and you'd have a range of different ages living within a community. And this guy was doing the study of the Hadza, who are a group of hunter-gatherers in Tanzania. And what he found was that actually over the course of 24 hours, there's barely ever a time when there isn't someone in this kind of extended family group who's awake. And they don't need to post kind of night watchmen to kind of keep watch over the camp for lions or other invading groups of people, because, there's always someone awake. But yes, so our circadian rhythms change in when we wake up and when we like to go to sleep with age, but they also tend to become flattened as we get older, because the lens of our eye begins to become more opaque, so less light gets through. What that means is that as you get older and age, you become less sensitive to the effects of light at night, but you're also less sensitive to the bright light during the daytime. So it's even more important to get outdoors during the daytime and see bright light in the day, which is a particular problem if you're in a care home. And actually in care homes, what you see is that in your dementia patients, there's this phenomenon called sundowning, where people become kind of more agitated in the late afternoon and evening. You get this kind of night waking, where people wake up in the night and kind of often have falls because they're confused and disoriented. But you find that these things are far worse in winter and on especially cloudy days in winter. So what researchers have been doing is looking at what would be the effect if we tried to not necessarily send people outdoors, because that's difficult if you have a group of dementia patients, but if we try to get more light into their eyes during the daytime. And in a trial that lasted about 3.5 years, comparing care homes that introduced these kind of bright lights in their kind of the places where most people congregated during the daytime, compared to care homes with kind of more normal light levels, they found that in the patients who were seeing more of this light during the daytime, it didn't cure their dementia, it's not a cure, but they did see a slower rate of cognitive deterioration. These people were experiencing fewer symptoms of depression, and they had less deterioration in just their ability to do everyday things like help get themselves dressed. And when they combined this kind of bright light during the daytime with giving people melatonin tablets to kind of reinforce that signal that nighttime is coming, they found that these people were getting better sleep. Anyway, to conclude really, what I think we need is we do need to get more sun exposure than a lot of us do at the moment. But I would never advocate that we should be going out there and getting sunburn and baking ourselves, not at all. But I do think it's really important to brighten our days and dim our nights. We don't have to go back to the dark ages to do that. We can use electric lighting just a bit more sparingly. So one thing I've done since my light experiment is I no longer have the bright ceiling lights on in the evening. I use just more table lamps. And I've also fitted these smart light bulbs in some rooms, like over my kitchen island, that I can kind of dim down in the evenings and tune out the blue light and make it more orange. But I also get outdoors a lot more during the daytime. And the other kind of key thing is to try and keep a regular schedule, which is important for your health, but particularly for your sleep. And that is the end of my talk, and I'm very happy to take questions.
Okay, thank you very much, Linda. We have time for maybe 1 or 2 questions with my lovely people on the microphone. And so if you pop your hand up, and if I can see. Oh, yep, there's someone just on the second row on the right-hand side there. And have you got one? Excellent. Those will be our 2.
Hospital high dependency units are typically lit up like a football stadium 24 hours a day. And I know from experience of friends who've come out of that, they've been very disorientated, mainly, I suspect, by the lighting conditions that they've suffered. Is there any possible solution that still gives them good care, but they don't have to be blasted by high-intensity light 24 hours a day?
Now, recommendations that intensive care units try to dim the lights overnight and increase the light exposure during the daytime. But it's still quite difficult in a lot of hospitals because they have this problem of small windows. But I think definitely dimming the lights at night helps. I mean, if one of my family members was ever in intensive care or in hospital just generally, I would be putting a sleep mask over them at night for sure. But researchers at the University of Manchester wanted to do a proper, randomized study of this in intensive care unit patients, putting a sleep, it's a really simple intervention, putting a sleep mask over one group of intensive care unit patients and just leaving the other group. And they couldn't get the funding to do it, which I think is incredible because it's such a small thing. But, there's really good reason to think that that would be a sensible thing to do. And if you look actually where it has been studied quite well is in premature babies. So you would think that premature babies don't necessarily, they don't have strong circadian rhythms really. They start to develop circadian rhythms in the uterus, but they're not certainly their sleep-wake rhythms, as anyone with grandchildren will know, are all over the place for the first couple of months. But if you take a premature baby and you cycle their light exposure, so you make it brighter in the daytime and then dimmer at night, what you find is that those babies do a lot better. And I think we should be doing this with all hospital patients. Yeah.
Thank you. And we had one just up here.
What can you do for somebody who dreams every night and wakes up like I did this morning and stopped my husband from getting up until I finished?
Do you mean, what do you do? What can you do if you wake up a lot at night? Or
not to dream, so I can get some deep sleep.
Oh, deep sleep. Well, I mean, REM, so you dream during REM sleep, and that's really important. It's important to get, and you probably are getting deep sleep and REM sleep, but it's, you're getting a lot of dreams, so it's just that you're remembering those dreams. But what you find is that actually if you're exposed to lots of bright light in the daytime, people do get more of that deep sleep. Another thing that I think to say about REM sleep, which I think is quite interesting, is that you tend to get more deep sleep towards the first half. So when you fall asleep, you tend to get more of that deep restorative sleep in the first half of the night, and then REM sleep tends to predominate during the second half of the night. So actually, if you're cutting short your sleep, what you're often doing is not missing out on the deep sleep, you're missing out on a lot of that REM sleep. And REM sleep isn't just important for dreaming, but it helps with the consolidation of memories, in particular your emotional stability. So a major problem with people not getting enough sleep and missing out on that kind of end bit of sleep is that their emotional stability, their ability to regulate their emotions is what suffers. So we all really need to be trying to get as much sleep as possible.
I feel like that's a very good note to finish on. Ladies and gentlemen, if you could give a huge round of applause to Linda Geddes. Thank you.
The first thing I wanted to look into was whether different SPFs, that is sun protection factor, which actually is supposed to indicate how strong the sunscreen is. But anyways, I wanted to see whether different SPFs of sunscreen look different under UV light. And then I wanted to compare whether high SPFs like SPF 100 are more effective than just regular high SPFs like SPF 50. Here was my thinking. With a UV camera, things that look lighter are emitting or reflecting UV light like the wall behind us. And things that look darker, like the shirt that I'm wearing, are absorbing UV light, which is something that I think you'd want to know when it comes to sunscreen, because UV light, ultraviolet light, of course, is part of the spectrum of light or electromagnetic waves from the sun, and UV is just on the far side of the violet part of the visible light rainbow, which means it's a wave that has a shorter wavelength, which means it has a higher frequency than any visible light. And in the end, it can do more damage to molecules like DNA or to cells. And as we all know, it's been linked to skin cancer. So my thinking was that if you look at your skin with sunscreen on, you should see that UV light is absorbed. So it should look darker. And yeah, like when we put the sunscreen on, it looked like face paint. We were even able to graffiti the side of the truck with sunscreen, but of course you can only see it with the UV camera. So my hypothesis was that the sunscreen with the highest SPF should look darker with the UV camera. And so we tested a bunch of different sunscreens with different SPFs on a grid on my arm, drawn with permanent marker. Here's what we saw.
So you can't see anything.
It looks just like the Sharpie.
It looks like paint.
Yeah.
It looks like metallic black paint.
Initially, we saw that, yeah, the low SPF areas do look less dark. You can tell they don't seem to be absorbing as much ultraviolet light. But interestingly, there's not a ton of difference between the 30 to 110 SPFs. And I've heard this rumor that SPFs above 50, anything really high, doesn't actually do anything more than SPF 50. So I looked into the scientific literature on this, and I actually found a study that came out just this year in May 2018 that tested 199 people with SPF 50 and SPF 100 sunscreens. Over the course of about 6 hours of sun exposure, the subjects got more sunburnt with the SPF 50. But they do put a nice little disclaimer at the bottom of the paper that leads you to conclude that more research needs to be done on whether there are more benefits over the long term of using SPF 100 versus 50. Hey guys, I just want to pause on this for a second because I still think it's weird that I had this conception that above SPF 50 you don't get any more benefits. And Derek, let me know what you think about this. But I think I've figured out where that conception came from, and I think that it's from a 2011 proposed rule from the FDA, the American Federal Drug Administration. Yeah, they proposed a rule that would limit the maximum allowed SPF labeling to 50 plus. Thoughts?
I also don't think it's strange, the conception that the high number sunscreens are all basically equivalent. You know, when I lived in Australia, people were limited to putting only 30 plus on the sunscreen bottles, and now they've moved that up to 50 plus. But it's still, I think, a good idea because as those numbers increase, you're getting kind of diminishing returns. So what's the difference between 50 and 100? Well, it's not really that much, because a lot of how effective they are comes down to how much you apply and how well you apply it. So, you know, I think it's just a marketing gimmick to say that, like, this is a 75 or this is an 80 or this is a 90.
So obviously SPF and the efficacy of different sun protection factors is still an active area of research. Anyways, back to the fun day at hand. When we were looking at the sunscreens with the different SPFs, we tried a different sunscreen with SPF 25 and something weird happened. It was actually lighter, like really light. This means that it's not absorbing UV light, but could it still be sunscreening? Yes, if it reflects UV light, which is most likely what's happening here with this sunscreen that has zinc oxide in it, which is a substance that's known to reflect some types of UV light. So, this is where I got really confused. I started looking up some sunscreen ingredients and what they do and why some are reflective and others are absorptive, and I ended up going down the rabbit hole of sunscreen controversies. I'll get to the discussion on health effects of different sunscreen ingredients in a minute. But I did find that Hawaii recently banned some sunscreens from the state. The reason why is that the ingredients oxybenzone and octinoxate were found to be contributing to coral reef bleaching, a process whereby coral polyps expel the little algae living inside of them. Actually kind of sounds like an exorcism, but it is in fact a bad thing. So starting in 2021, Hawaii is banning any sunscreens with those ingredients. This ban was based off of recent research, which begs the question, are the health effects and environmental effects of sunscreen ingredients not well known? Okay, I'm just gonna pause here again because I feel like this is a good discussion for us. There's a lot to unpack here, but I wanna start out with that SPF 25 sunscreen that was really reflective.
Yeah, I mean, there's two major ways that sunscreens can protect your skin from UV light. One of the ways is by absorbing that light and turning that energy into heat. Another way is by reflecting the light. And what you saw was clearly more reflection. Now, in the media, they're often called physical versus chemical sunscreens, which is maybe not the best designation.
I don't think it's the best.
Because, you know, they are all chemicals. Maybe it's a better distinction to say that the chemical sunscreens are organic because they are organic molecules. They have these chains of carbon. And the so-called physical sunscreens are inorganic molecules, things like titanium dioxide and zinc oxide. So they do a bit more reflection, but they also do scatter the light, they absorb the light.
This chemical versus physical distinction bothers me, as you know, because I think it's used in a misleading way on a lot of health blogs and in a lot of media, indicating you should avoid these chemical sunscreens because they're chemicals.
You don't like it?
I don't like it.
Because they're all chemicals.
Right,
Everything's a chemical.
Right.
I think there is sort of a deeper reason why people would say chemical versus physical, because chemical could describe, like, by virtue of its chemistry, that's how it interacts with the light. Whereas, you know, a physical sunscreen, by virtue of its structure, is really how it interacts with the light. You're right, when it comes to the marketing, people do try to use the chemical label as sort of a negative term.
And I think that it actually hides an important discussion about the potential safety issues of what they call chemical sunscreens. So we're discovering things about sunscreen ingredients all the time. For example, recent research has shown that some sunscreen ingredients, and in particular some of the organic sunscreen ingredients, can get into the bloodstream and into breast milk through your skin, which led the FDA to recently state that this is a significant discovery that needs to be considered as we continue to evaluate the health and safety of sunscreen ingredients. In fact, the FDA just recently rejected 8 new proposed sunscreen ingredients
because they felt there wasn't enough science to show that these ingredients were safe.
But my question is that now that we know sunscreen ingredients can enter the body through the skin, should we be looking back at those 16 ingredients? Should we be looking at them through the lens of the new research and judging them with the same thoroughness that we're judging these 8 new ingredients against, for example?
What's surprising to me is that there is still so much to be learned about sunscreen. I think it's a little weird because on the one hand, you're saying these health blogs are saying chemicals bad, but on the other, you're saying, well, maybe chemicals are bad because they haven't been really tested yet.
That's not why people are saying that they're bad. And in fact, some of them may be perfectly fine and they get lumped in with the ones that do cause skin allergies. Like, to say because they're chemicals is the reason, like, you might lose out on potentially a ton of great sunscreen ingredients that are going to be really effective for protecting the populace against skin cancer, but people have lumped them into this chemical category, which really just means organic molecule category. Maybe we're going to find ones that don't get absorbed into the bloodstream as readily. You know what I mean?
Yeah.
There is so much to be learned.
But at the end of the day, I think put on the sunscreen.
They've been telling us that everybody is a lot more on edge than they've really been the whole process, because this is a really high stakes day. Like, this is the best view in the house right here, is to see when this cover is lifted off and we get to see the lenses.
Hey, I'm Diana, and you're watching Physics Girl. That footage was a challenge to get because we had a short window of a few hours to make it to a warehouse in Menlo Park, California to be there for the reveal of a pair of lenses going on the world's largest digital camera. I traveled to SLAC National Accelerator Laboratory to join a very excited group of scientists and engineers working on the camera. And why did I want to see these lenses so bad? Well, one reason is that no one ever gets to see lenses like this. Perfect, massive pieces of glass like this are usually kept in clean rooms, away from mere mortals like us, because these are not ordinary camera lenses.
This lens system is 2 lenses, and the whole system together costs $20 million.
And these lenses will become part of the camera going on the Large Synoptic Survey Telescope, which is the latest telescope that's going to attempt a giant sky survey. Sky surveys are like taking giant panorama photos of the whole sky. Okay, so imagine the sky is a jungle and you're looking for a cougar or something like that. You have the whole picture. But then the LSST is going to take this panorama photo of the entire sky in the southern hemisphere every 3 nights approximately for 10 years.
We will collect
more data in the first year than every other telescope combined has ever collected. And then we'll do that for 10 years.
Ever in history?
Yes. Yes, history.
That is insane.
Like, ever.
So you could hypothetically see how the whole population of cougars has changed, or something like that. But first, you need a camera for your telescope, and for that you need some perfect, one-of-a-kind camera lenses.
So this was like the only chance to see the lens because it's just going to be covered and...
Yes.
Well, we feel very lucky.
It's good. I'm glad you're here.
Our goal is to stay out of everybody's way, do nothing wrong,
Right.
and not...
Yeah. You're correct.
Mess
There is
anything up.
definitely there's a lot of nervous energy today.
There was a lot of nervous energy. The head scientists and engineers were lying on the floor to get a good look, and people were being really careful even before the lens was unveiled.
So we just got a safety debriefing where we were told what to do if the giant dewar of liquid nitrogen spilled all over the floor, or in case of earthquake. So we're prepared. Everybody's here. There's a crowd. It's great.
As they lifted off the lens cover, they had to use an overhead system with strong polyester straps and had to keep the cover sliding along vertical poles so it didn't swing and accidentally bump the lenses. Any bump could be catastrophic to these lenses. The first thing that was unveiled underneath, very slowly, was the L2, the smaller of the two lenses that you can see here. I thought that was it. But the more impressive lens, the L1, was still to come. The L2 and L1 are all part of a system designed to make the best, crispest, is that a word? Crispiest images possible.
If you were to put a golf ball at the same distance away from Earth as the moon, we'd be able to see it with our camera. The moon is 80 million times bigger than a golf ball. Like, that's absurd.
They want really sharp images, so they need a massive telescope with 3 giant mirrors, the largest of which is the size of a tennis court, which by the way was only limited by the size of the tunnel that they had to transport it through to get to the Chilean mountaintop, which is where this telescope is going, by the way. I was thinking, wow, they're being so careful with everything, and this lens is going in a telescope. There's no way they're gonna let us in the clean room. But then they did. And I'll show you guys the other hidden parts of the camera being assembled in the clean room. But first, the L1.
I feel like you don't get to see this part of the process of science very often. Like, you see the end result of science usually, but you don't see the process. You don't see the incredibly impressive equipment that's made.
That's the second reason I was so excited to be there. We got to experience such a hidden part of the process of science. So we're looking at this piece of glass and we're like, wow, that's beautiful. What a piece of equipment. But it was easy to forget that this is a camera lens. Usually camera lenses look like this. Or like this. The one we were looking at, that piece of glass, is a 5-foot marvel. It looked like a perfect water droplet. These lenses are made of fused silica, which is a material often used in fiber optics due to its purity and the fact that it's transparent to a wide range of colors of light, which makes it perfect for astronomy where you want to see infrared, ultraviolet, visible light, all different colors of light coming from the stars.
That was really cool.
What took place next was a thorough inspection of the camera lenses for anything unexpected. And then the lenses were covered up and tucked away in the corner of the room. So this really was our only chance to see the lenses, because then they're going to be put into the camera and then you'll never see them because they'll be in a telescope. While the lenses were awe-inspiring, I honestly think the most impressive piece of equipment was the 3200 megapixel sensor.
250 times better than your iPhone. It's a little more than half a basketball court with 4K TVs in order to display one raw image from our camera.
Let's go take a look at it. Well, it's not assembled yet, but let's look at what they've assembled of it so far. We had to get in clean room garb because the sensors were being tested and assembled in the back of the clean room. Those shiny black squares are the CCD sensors, or charged coupled devices. Whenever photons of light come in from a star or another source and hit the sensors, electrons are released from the material and they collect at the surface. Electric charge then builds up relative to how much light hits each area, and the amount of charge is then detected and converted into a digital image. But the telescope will be collecting light from a variety of very dim sources.
We're seeing incredibly dim light.
Yeah.
Like, any star that you can see with your eye would just totally saturate our focal plane. Like, we are seeing so far beyond the human eye, it's kind of absurd.
So you only get a small number of photons, and so any stray electrons could ruin the image. And one thing that always introduces chaos, heat. So the whole thing needs to be cooled.
So we were talking earlier, everything is I don't know what words you use. What are the technical terms? Cooled. Specifically, the sensor and electronics piece of the camera, all cooled down, all under vacuum?
Yes. So the electronics are at -40 Celsius,
wow.
and the sensors are at -100 Celsius.
Oh my gosh.
Very cool.
In addition to this impressive sensitivity, the camera will be able to see visible light, but also light from the near ultraviolet to near infrared wavelengths using special filters. So what are we aiming to see with this telescope over its 10-year run? Well, a lot of things, because you could use it for whatever you want to look for in the sky, but hopefully something to do with dark matter.
We take an image of the entire southern hemisphere sky every couple days, and you can plot really precisely where all the stars are, where all the galaxies are. You can plot with such precision that when planets and galaxies move in a way that you didn't expect, you can infer that there's other stuff there that you can't see, dark energy, dark matter.
Stuff that you can't see seems promising, but scientists have other goals as well.
There are things called variable stars that get dimmer and brighter, and the reason is because they're oscillating. And so you see a smaller or a larger effective area, and then, you know, for things like asteroids, things pop into your field of view suddenly.
There's so much potential for the LSST, but it has to be finished first. Today was a huge milestone to see the lenses that for a long time were just an idea for these scientists. So the day we visited was exciting.
It's pretty incredible just to see how real the camera's getting right. I've seen it on my tiny computer screen for 4 years now. It looks so small, I can like hold it in my hand, but it's actually ginormous.
I cannot wait to start seeing the results of this telescope, but I'm gonna have to be patient because it's not scheduled to be completed until 2022. In the meantime, though, you can follow the progress of the telescope on the LSST website at lsst.org. They're documenting the entire build process, and there's a lot more about the project that I did not get into.
And to close, I will show NASA's view of all the moon phases for the entire year. So for example, every single frame is 1 hour difference of what the moon looks like for the entire year. Which means that, for example, when you have an eclipse, say during the year, and you want to know what the moon is going to look like on that particular night, you just scroll forward to the particular frame of that day and that hour, and you get exactly what the moon is going to look like, complete with everything labelled on it. So I'll play this. It goes for a couple of minutes, and then we'll call it a night. What you're actually seeing here, aside from the look of the moon, and it shows the main features on it, the craters and the Mara, and also it will show the Apollo landing sites. You'll notice the horizontal line with numbers on the right hand side, 28, 30, 32. That's the distance that the moon is away from the Earth. So the Earth is shown over here on the left, goes out to 32 Earth diameters over on that side of the Earth. So you can actually see where the moon is in its orbit as we go through. This shows you where the moon is around the Earth in its orbit, and this shows its tilt on it as well as you go through. And here we go. Well, thank you very much for coming tonight. The next meeting of the Society will be in January, because we don't usually have a December meeting of the Society. So thank you very much for coming.